Okay, this is question 7 from the Limpopo June 2019 question paper. Two small metal spheres B and C on insulated stands carry charges of plus 2 times 10 to the negative 9 coulombs and minus 6 times 10 to the negative 9 coulombs respectively. How does the number of electrons on sphere B compare with the number of protons on sphere B? Choose your answer from one of the following: less than, more than, the same, whatever. Give a reason for your answer. So now they said to you, only look at sphere B because it's got the number of electrons on sphere B with the number of protons on sphere B. So this sphere B has a positive charge. So if it has a positive charge, it has lost electrons. So how many electrons are there? They are less than. Sphere B is positively charged, which means it has lost electrons. Okay, remember, only the electrons can move, so we always like to talk in terms of what has happened to the electrons. The spheres are allowed to touch, after which they are separated again and returned to their original position. State the principle of conservation of charge. Remember, you have to learn this definition. There's nothing you can do about it. So the principle of conservation of charge is that the net charge of an isolated system remains constant during any physical process. For instance, exactly what's happened here, two charges making contact and then separating. So it just means that the total amount of charge before contact is equal to the total amount of charge after contact. That's what that net means. In which direction are the electrons flowing while spheres B and C are in contact? So now remember, only electrons can flow, and they want to average themselves out. So they'll go from where there's a lot of electrons to where there is a deficiency of electrons. So there are way too many electrons on here. So they are going to go from C to B. Briefly explain the answer to your question. Why do they go from C to B? Okay, we must explain this nicely in short sentences. C has an excess of electrons. B has a deficiency, or you can say less. Okay, only electrons can move. So electrons flow from C with the excess to B, which has less electrons. Remember, everything wants to average itself out. So we flow from a high electron concentration to a low electron concentration. Now it says calculate the charge on each sphere after they are separated. So how are we going to do this? Remember, we have our data sheet and they show you this formula. There's two electrostatics formulas plus the charge on an electron. So it tells you this is the formula for conservation of charge. The charge is equal to the total of the charges divided by the number of charges. That's basically an average. So if we go here, we're going to use Q equals Q1 plus Q2 over 2. This is Q1, this is Q2. You add them together, you divide by 2. Look, here's the calculation here. 1 mark for writing the formula. Remember, you always have to write the formula. So you have to write Q equals Q1 plus Q2 over 2. Take the charges, a positive charge, a negative charge. You must add them together. You end up with negative 4 times 10 to the 9 divided by 2. You end up with negative 2 times 10 to the 9. No unit, no mark. You must put the C for coulombs. State the principle of charge quantization. This is also a definition you have to remember. All the charges in the universe consist of an integer multiple of the charge on one electron. Calculate the number of electrons transferred between the two spheres. So now remember, if we want to go from a charge to a number of electrons, we use this formula, N equals Q over E. Okay, so I'm just going to write this here, N equals Q divided by E. I'm putting Q over E, Q divided by E, it's the same thing. But what you must first think of here is what has actually happened. There has been a change in electrons with this transferred here. Okay, so the transferred, how are we going to work out transferred? It's the change, okay, and the change is always equal to the final minus the initial. So if we want to find the number of electrons transferred, it's going to be the final charge, and look, here's the final charge, okay, minus 2 times 10 to the negative 9. It's so irritating when it does that. Okay, so minus 2 times 10 to the negative 9 is your final charge. What was my initial charge? And it doesn't matter which sphere you pick. You can pick either sphere. Okay, I'm going to pick this one. So it is plus 2 times 10 to the negative 9. So a minus and a plus stays as a minus. So I don't know why that thing decided to shoot up into the air there. So if I've got minus 2 times 10 to the negative 9 minus another 2 times 10 to the negative 9, I end up with negative 4 times 10 to the negative 9. It's very irritating when it does that. Okay, so that is how much we transferred. You can't just use this charge that's on the sphere at the end. It didn't ask you how many electrons are on the sphere. It asked you how many were transferred. So you have to know what you started with and what you ended with, and then you find the difference, and those are the electrons that moved. So then once we found this value, we can say N equals Q divided by E. Make sure you write the formula. And then this value, okay, so N is going to be equal to how many electrons were transferred divided by the charge on one electron. Where do we find the charge on one electron? We go back up here to our data sheet, and they tell you the charge on the electron is 1,6 times 10 to the negative 19. So we come in here and we write it's a negative charge, 1,6 times 10 to the negative 19. So then if you put that into your calculator, you will end up with a very large number of electrons, which is not a surprise because there are a lot of electrons in the world. So this is times 10 to the power of 10 electrons. So this is how you do it. Make sure that you remember that you have to figure out how many were transferred. You can't just say, oh, this is my charge, I'm going to work out how many electrons there are. You have to say, what was my change? How many were transferred?